Hey guys, Mr. Bowman here. Today's learning objective is in blue and we are learning to calculate the A, B, or C in inverse normal distribution questions. So the first thing, what does this ABC mean? But just a friendly reminder, the A always relates to the minimum of your triangular distribution. The B, that relates to the maximum, and the C, that relates to the most likely outcome or your peak of your data. And then our X value that we're interested in here is 17. So we're looking at an inverse question. So that question means you're given a probability normally. And from our question, I'm going to say that the probability of someone falling between 17 and 8 or 20 is about 15% or 0.15. And our goal today is we're trying to inversely work backwards to figure out an A, B, or C value. So this question is going to focus on C, but the same approach would apply if you're calculating A or if you're calculating B, just the numbers would be substituted into different areas. So let's start off with our normal thing, our formula. So we know the probability of X is going to be greater than 17. That should be equal to 1/2 of base times height, because that's the area or the formula for our triangle. We know that probability, that's already equal to 0.15, and that is going to be equal to 1/2 times the base. And the base of this triangle is 20 minus 17, which is 3. And that is going to be times by the height of this triangle. And here we're going to look at the formula. If it was on this slope here, just a reminder, you'll be using your left slope formula. So don't use your right slope formula for a left slope question because your answers will be wrong, unfortunately. And here we're dealing with the right slope, and that's what we've got. And that formula I've got written down here. It's 2 times b minus x divided by b minus a and b minus c. But just a strong emphasis, make sure you're using the right formula for when you're calculating A, B, or C, depending on left or right slope. We now want to start simplifying and doing the math a bit more. So 0.15, that is going to be equal to 3/2. So I've simplified that part there. And that is going to be multiplied by 2b minus x. So b is 20 and x is 17. So that is 20 minus 17, close bracket, and that is going to be divided by b minus a. That is 20 minus 10, and then b minus c. And one thing I want to emphasize is minus c. I've left that in C form because we don't know what C is. We're trying to calculate that. And if you notice in the whole equation, there is one variable, and we can go away and mathematically calculate that. The other thing I want to note is if you're calculating A or B, you would have either the letters based on that formula, you would have either the B's in the formula or the A's in the formula. And I just want to note, there are 3 B's in our initial formula, so that's a lot harder to calculate than the A's or the C's, but the same process does apply, just the maths and algebra is a bit more annoying. Okay, so let's carry on simplifying our work. So we're going to move this times to 3/2 to the other side. And we're going to make that divided by 3/2. And that is going to be equal to 2 times 20 minus 17, so that's 2 times 3, which is 6. And that is going to be divided by 20 minus 10, so that becomes 10 of 20 minus c. We'll quickly rearrange this one here, so that there becomes, well, let's do that on the calculator actually. So that's 0.15 divided by 3/2, and that becomes 0.1. So 0.1 is equal to 6 divided by, let's take this over, so that's expanding that bracket down the bottom, that's 200 minus 10c. Let's then carry on with algebra. You can use the solver function of your graphics calculator here if you want to, but that's 0.1 times 200 minus 10c. That is equal to 6. 0.1 times 200, that's 20. 0.1 times 10 is minus c equals 6. So negative c is equal to, negative c is equal to 6 minus 20. So negative c is equal to negative 14, and we can ignore the negative signs of both of those sides. So what we've done here is we figured out the most likely outcome in our triangular distribution, or the peak of our triangular distribution. We've inversely figured that out to be 14. Just a reminder, you can use the same approach to calculate A or B as long as you have all of the others in that. And the other thing I want to emphasize yet again, make sure you're using the right formula. We're using the right slope formula for this question because we have a right slope problem. But if you did have a left slope question, make sure you're using the left slope formula. Hopefully you found today's video useful. Now let's get into some more questions.